Warning, your legs weaken first. Eat these 10 foods to strengthen them. As we advance in years, a subtle yet significant decline in leg strength often begins long before we consciously notice any dramatic change in our physical capabilities. This insidious weakening can progress to a loss of control, a precarious imbalance, and for an alarming number of older individuals, it culminates in a devastating fall. Falls are tragically the most common cause of traumatic death among the elderly population, a grim reality that nonetheless does not have to be our inevitable fate. We possess the remarkable ability to counteract this decline through mindful, straightforward lifestyle adjustments. Welcome, health champions, to a discussion that transcends superficial advice. Today, we delve into the foundational elements that support lower limb strength, moving beyond the often misleading surface-level recommendations found elsewhere. It has become increasingly apparent that many circulating health videos offer advice that is, frankly, random and misinformed. Those creating such content often lack a deep understanding of true physiological health, grasping at straws by focusing on simple nutrient associations. They might point out that sweet potatoes contain potassium and declare potassium essential for signaling, thus recommending sweet potatoes without context. They discuss leg weakness, labeling it sarcopenia, yet fail to grasp the underlying mechanism, merely describing a state of muscle loss or weakness without explaining its causes or comprehensive implications. Similarly, they might argue that because muscles require energy, oats, with their complex carbohydrates, should be consumed for sustained energy, while sweet potatoes and oats are not inherently the worst dietary choices if one can tolerate a certain carbohydrate load. Mentioning them in isolation based on a single nutrient fact is deeply misleading. The notion that simply consuming these items will magically lead to regeneration and strength is a gross oversimplification. That is not how the human body functions. Here we aim to provide the comprehensive picture. The paramount question we must address first is why this topic garners so much attention. Why are weak legs such a significant danger as we age? As mentioned, impaired leg strength directly translates to a diminished capacity for balance and control, drastically elevating the risk of falls. A fall, as stated, is the leading cause of fatal trauma in the elderly, and even a seemingly minor fall can result in a hip fracture. A hip fracture incapacitates an individual, leading to a prolonged period of immobility. This loss of mobility has profound consequences. I have often emphasized that the primary purpose of movement is to continuously fuel the brain by sending signals to it. When we lose mobility, we risk losing cognitive power. Brain strength diminishes. Consider a muscle placed in a cast. Without sufficient signaling, it begins to atrophy, to shrink. In a similar, though often slower process, if the brain is not adequately stimulated through physical engagement, it too can begin to degenerate. Such significant degeneration can ultimately lead to a loss of vitality and even premature death. The statistics surrounding falls are quite sobering. Up to 50% of individuals who suffer a hip fracture pass away within 1 year of the event. Even for those who survive, their quality of life is often permanently altered, with as many as 60% requiring long-term care. Yet, this trajectory is one we can genuinely reverse through targeted lifestyle interventions. Prevention, fundamentally, relies on two critical pillars: exercise and nutrition. Exercise is relatively straightforward in principle. It helps build muscle because physical activity creates micro-tears in the muscle fibers, and during the subsequent recovery phase, the body repairs these fibers, ideally making them stronger than before. However, this leads us to the crucial second step, signaling. Exercise provides the necessary signal and challenge that prompts the body to initiate this repair process. If a person is completely sedentary, any minor muscle fiber breakdown that occurs due to daily activity or disuse is not met with a robust repair signal, meaning the tissue does not rebuild or strengthen to its previous capacity or beyond. While exercise is conceptually simple, and I would be happy to dedicate a future video to optimal routines if you express interest in the comments, the greatest area of confusion revolves around diet. This is precisely what we aim to clarify today. Food provides the building blocks necessary for muscle repair and maintenance. The ideal diet must supply the body with the right kinds of fuel, along with the necessary catalysts, vitamins, and minerals required to manage the biochemical reactions involved in muscle synthesis and maintenance. A detailed look at nutritional needs suggests we require quality fats for fuel, an appropriate amount of carbohydrates, tolerated based on individual metabolic status. I reiterate that I am not a proponent of high carbohydrate diets for those with diabetes or carbohydrate intolerance, where very low carb or ketogenic approaches are often superior. High-quality proteins, essential fatty acids, and a spectrum of vitamins and minerals. However, even meeting these basic macronutrient and micronutrient requirements is insufficient, as we must consider the bigger picture: individual metabolic health. The optimal food choices for a 20-year-old endurance athlete differ significantly from those for an older individual managing insulin resistance. Furthermore, diet must actively combat neuroinflammation. Many people struggling with chronic low-grade systemic inflammation also experience neuroinflammation, meaning their brain and nervous system become inflamed. Inflammation in the neural pathways compromises proper signaling. Therefore, the food we consume must support the neuromuscular junction. Without effective signals traveling from the brain to the muscle, even the best structured muscle fiber is functionally inert. This brings us directly to coordination and balance, a combination of muscle presence and signal integrity. If the nervous system is compromised by inflammation, the performance potential of the muscle cannot be realized. Why do the legs specifically seem to weaken more rapidly than other muscle groups? In cases of complete immobilization, such as a coma or strict bed rest, significant muscle mass loss, up to 50%, can occur in just 30 days. In a profound sense, the consistent sedentary lifestyle many adopt over decades mirrors this atrophy, albeit at a much slower pace. Over the course of a sedentary life, we can lose a comparable 50% of quadriceps strength by the time we reach our 60s, representing a decline of about 5% to 7% per decade within that age bracket. The legs often show accelerated deterioration because they typically contain a higher proportion of fast-twitch muscle fibers compared to the average muscle elsewhere in the body. These fast-twitch fibers are more prone to atrophy and tend to break down more quickly when not challenged regularly. Now let us explore the top 10 foods that actively support leg strength and neuromuscular health, presented without any specific ranking as their importance is holistic. Number 1. Eggs, consumed whole, including the yolk. To reap the full spectrum of benefits, eggs must be eaten whole. Complete eggs are rich in the essential amino acid leucine, a key driver of muscle growth via the mTOR, mammalian target of rapamycin pathway, a fundamental cellular mechanism that triggers muscle protein synthesis. Beyond muscle building blocks, eggs are an exceptional source of choline, a precursor to acetylcholine, the primary neurotransmitter responsible for activating muscle contraction. Furthermore, eggs provide vitamin B12, which is critically important for nerve signaling. A deficiency in B12 can lead to compromised signaling because this vitamin is essential for maintaining the myelin sheath, the insulating layer surrounding our nerve fibers, the body's internal electrical wiring. Healthy insulation ensures that nerve signals travel rapidly and unimpeded. Eggs are also abundant in essential fatty acids, specifically EPA and DHA. These fats are vital components used by the body to construct the correct structure for cellular membranes in every cell, crucially including nerve cells and muscle cells. With the right types of fats in the cell membranes, the proteins responsible for muscle function can operate optimally, leading to superior signal reception and transmission, alongside a ready supply of amino acids. In fact, after human breast milk, eggs are often cited as providing the highest percentage of readily available amino acids for human utilization. It is imperative to consider the quality of the egg. Pasture-raised eggs from chickens allowed to roam outdoors, forage for insects and grass, and receive natural sunlight contain 2 to 7 times the concentration of these vital nutrients compared to conventionally raised counterparts. Number 2. Salmon and other cold water fatty fish, sardines, mackerel. Fatty fish like salmon represent the most potent dietary source of the critical long-chain omega-3 fatty acids, EPA and DHA, which we mentioned were also present in eggs. These fats play a significant role in modulating the body's inflammatory response. While not an acute anti-inflammatory like a pharmaceutical drug, a consistent intake helps the body maintain a healthy balance of inflammation, resulting in an overall anti-inflammatory effect. Research indicates that adequate intake of these fatty acids can enhance muscle protein synthesis, particularly in older adults. As with eggs, sourcing matters. Wild-caught salmon typically exhibits a far superior omega-6 to omega-3 ratio, often 1.4, with the higher number being the beneficial omega-3 compared to farm-raised salmon, which might be closer to 1.1 or 1.2, though still generally better than many common Western staples. To put this in perspective, if dining out and choosing between industrially produced chicken and farm-raised salmon, the salmon remains the vastly superior choice over highly processed carbohydrate-heavy options like bread and cheese. Salmon provides high-quality, highly bioavailable protein, nearly rivaling that of pasture-raised eggs. Moreover, salmon contains powerful antioxidants like selenium and astaxanthin. By reducing oxidative damage to mitochondria within muscle and nerve cells, these compounds decrease the likelihood of cellular breakdown. The fatty acids in fish also support mitochondrial function, enhancing energy production in muscles and fortify nerve membranes, the structures responsible for sending signals, thus promoting improved strength, balance, and energy output across the board. Number 3. Grass-fed beef. Grass-fed beef is a powerhouse, notably containing creatine. Creatine is foundational in muscle performance, serving as a crucial phosphate donor in the ATP-ADP cycle, the body's mechanism for rapidly transporting and accessing energy. By increasing creatine stores, we facilitate a faster regeneration of ATP, allowing for more sustained high-intensity effort. Beef is also exceptionally rich in highly bioavailable iron. Iron is indispensable for red blood cell formation, ensuring an adequate supply of properly sized cells capable of efficiently transporting the oxygen necessary for muscle function, growth, and repair. Compounding this benefit, beef is a major source of vitamin B12, which aids in red blood cell maturation and, crucially, supports nerve conduction. The combination of efficient oxygen delivery and robust nerve signaling is fundamental to muscular performance. High-quality beef is also rich in zinc and constitutes a complete, high-quality protein source, providing the necessary amino acids for muscle rebuilding. The distinction between grass-fed and grain-fed is significant. Grass-fed beef often contains up to 5 times more beneficial omega-3 fatty acids and 2 to 3 times more vitamin E and conjugated linoleic acid, an antioxidant. If accessible, opting for grass-fed, even in an affordable format like ground beef, is strongly recommended. However, if grass-fed is unavailable or unaffordable, conventional beef remains a far healthier option than heavily processed, sugar-laden, or inflammatory foods. Number 4. Unsweetened. Full-fat yogurt, preferably Greek or cultured. When selecting yogurt, the goal is to maximize protein content while embracing natural fats. Full-fat Greek yogurt, for instance, is strained, resulting in a higher concentration of protein. Ideally, seek out full-fat versions, as low-fat alternatives in many markets have had unhealthy fats added back to compensate for texture loss. The fermentation process itself is highly beneficial. Aim for products described as starchy or highly cultured, as this indicates that the bacteria have consumed a significant amount of milk sugar, lactose, resulting in fewer residual carbohydrates and a higher population of beneficial bacteria. If possible, making your own yogurt allows for complete control. A healthy, functional microbiome is essential because it supports the gut-brain axis. A properly functioning gut reduces systemic inflammation, much of which originates from undigested food particles leaking into the bloodstream due to an unhealthy gut lining. Furthermore, yogurt is a fantastic source of calcium, which is non-negotiable for proper muscle contraction, and high-quality animal protein required for for muscle integrity. Number 5. Bone broth. Bone broth is a traditional preparation rich in collagen, which supports the repair and maintenance of joints, ligaments, and the gut lining. As we discussed regarding the gut, improving its integrity reduces inflammation and enhances nutrient absorption, thereby delivering more fuel to the muscles. Maintaining healthy connective tissues is also vital for strength. Pain in joints or ligaments signals the brain to inhibit muscle activation to protect the structure, thereby reducing mobility and perceived strength. Beyond structural support, bone broth is loaded with the amino acid glycine, known for its role in reducing chronic inflammation and promoting neurological quiescence, calmness. It is also rich in glutamine, which aids in healing intestinal permeability, leaky gut, and helps mitigate neuroinflammation. This ties directly into the gut-brain axis. An inflamed, leaky gut allows inflammatory substances to cross into the brain, which is why addressing gut health is paramount for optimal nerve function and subsequent muscle control. Number 6. Non-starchy vegetables and leafy greens. This category allows for high volume consumption without overloading on carbohydrates or spiking blood sugar. Leafy greens and non-starchy vegetables are exceptionally dense in essential minerals like magnesium and potassium, as well as B vitamins and vitamin K1. They are also a primary source of dietary nitrates, which the body converts into nitric oxide, a potent vasodilator that improves blood flow and circulation to the muscles. These vegetables are renowned for their anti-inflammatory properties, largely due to their high concentration of polyphenols. While some inaccurately label these beneficial plant compounds as plant toxins, they are crucial. They serve as necessary fuel and diversity enhancers for our gut bacteria. A wider variety of these compounds supports a more diverse and robust microbiome, which in turn reinforces the gut-brain axis and reduces systemic inflammation. These nutrients also play a vital role in fueling mitochondrial processes, serving as essential catalysts rather than direct energy sources themselves, helping the mitochondria efficiently generate cellular energy. Number 7. Nuts and seeds. Nuts and seeds are excellent sources of crucial minerals like magnesium and zinc. Certain seeds, such as flax seeds and chia seeds, provide omega-3 fatty acids in the form of ALA, alpha-linolenic acid. While the body converts ALA into the active forms, EPA and DHA, very inefficiently, this plant-based omega-3 still contributes positively to maintaining a favorable omega-6 to omega-3 balance. Nuts and seeds also contribute vitamin E and protein. How do these support leg function? Muscle contraction and relaxation require a precise interplay of electrolytes: sodium, potassium, calcium, and magnesium. When these are in the correct ratios, muscles can contract powerfully and relax fully, preventing cramps. Furthermore, these minerals and the vitamins present are essential for nerve transmission, which underpins tissue repair and the generation of the small signaling molecules known as neurotransmitters necessary for leg control. Number 8. Legumes, beans, lentils, chickpeas. Historically, I have focused less on legumes in content aimed at very low-carb or ketogenic adherents, as they contain moderate levels of carbohydrates. However, for those whose metabolism tolerates them, legumes offer significant benefits. They provide protein, potassium, iron, B vitamins, and, importantly, unique types of fiber and polyphenols that nourish the gut bacteria. The specific fiber profiles in many legumes act as prebiotics, feeding beneficial strains. Additionally, these beans contain precursors to nitric oxide synthesis, contributing to better vascular dilation and blood flow. Incorporating legumes, provided they fit within an individual's overall carbohydrate tolerance, diversifies the microbiome and supports the gut-brain axis, aiding in the reduction of inflammation. Number 9. Berries, raspberries, blueberries, blackberries, strawberries. Berries are nutritional giants, high in fiber, nutrient-dense, and relatively low in sugar and carbohydrates compared to many other fruits. Their standout components are anthocyanins, potent compounds found in deep-colored berries. Anthocyanins have been linked to promoting the production of BDNF, brain-derived neurotrophic factor. BDNF is often described as the brain's miracle grow, essential for creating new neurons and forging new synapses, the critical connections needed for complex motor learning. If the goal is to strengthen the brain-to-muscle connection, improve coordination, and build functional strength, fostering the pathways that BDNF supports is vital. Berries also positively influence the microbiome, reinforcing the gut-brain axis, enhancing blood flow to both muscles and the brain, and evidence suggests they help preserve the function of those crucial fast-twitch muscle fibers we discussed earlier. Number 10. Avocados. The avocado is perhaps the closest thing to a perfect food from the plant kingdom. It is saturated with healthy fats, predominantly monounsaturated fatty acids, which are pivotal in reducing systemic inflammation by replacing more inflammatory fat sources in the diet. Avocados are also packed with essential minerals and vitamin E. Crucially, they supply vitamin B6, which is a necessary cofactor in the synthesis of neurotransmitters, the very signal molecules that bridge the gap between nerve and muscle. To build muscle and maintain control, you need more than just bulk protein. You need functioning signals. In summary, strengthening your legs and preventing the devastating consequences of falls requires a multifaceted approach that integrates targeted exercise with a comprehensive, metabolically supportive diet. You cannot rely on a single ingredient. True health mastery comes from understanding how the entirety of these food groups work synergistically to support muscle, nerve conduction, energy production, and systemic anti-inflammation. If you would like to see a dedicated video on designing a routine specifically aimed at building powerful, resilient legs, please let me know in the comments below. If you found value in this breakdown of how the body truly functions to support strength and longevity, please remember to subscribe, hit the notification bell, and turn on all alerts so you never miss a potentially life-saving piece of information.